All right, I'm just going to go over our test a little bit. Sometimes it's hard to give individual feedback to everyone, so I thought I'd just go over some of the common errors. So here, create an equation for a function that satisfies each of the following sets of features. So each student should have a unique answer for each of these. So function 1, we want a horizontal asymptote at y equals 0, at least one vertical asymptote, and at least one hole. But for each of these functions, you have to explain how you know it satisfies the set of given conditions. All right, let's start with this one. F of x equals 2x plus 4 over x plus 3 cubed, x minus 3 squared, and x minus 4. Maybe that says x minus 4 here. It looks like it says x minus 4 because I think they're looking to put a hole here. Comma x can equal 4. You don't really have to put comma x can equal 4 because the fact that there's an x minus 4 on the bottom tells us, like, if you plug in an x equals 4, you're going to get an undefined answer. So you don't really have to put comma x can't equal 4. It can't. You don't need to tell us that. It's already told to us because you just can't plug it in, right? So there's a hole at 4 comma 0, it looks like it says. The degree on the bottom is bigger than the degree on the top. The horizontal asymptote is at y equals 0. Negative 6, 0 and negative 2, 0 are vertical asymptotes. All right, so I have a few comments here. So f of x, that's awesome. But I do have an issue with pretty much the whole class uses f of x for every single function that they do. But when there are two different functions in the same question, if they're not exactly the same, then you can't call them both f of x, right? You have to start using g of x, h of x, and get used to it, because when you have two different functions, if they're both called f of x, then when I want to call f of 3, like when I want to plug in a 3 and I say f of 3, I don't know which function to put it into, and I might get two different answers. So that's a major issue. So I did notice that everyone loves f of x. Let's start using g of x, h of x, and other things. But so far so good here. All right, there's a hole at 4 comma 0. All right, since this is a test, I would expect that you would want to give me evidence that there would be a hole at 4 comma 0. Right, so something that shows me that there would be a hole. Maybe there would be a graph that goes along with this. Maybe there would be you input some values to show me that. That never really happened, right? So in terms of communication, this has to be your best product, right, when you're doing a test. So just telling me that there's a hole at 4 comma 0 isn't enough. That's assuming there is a hole at 4 comma 0. Let's double check that. Obviously, if I plug in f of 4, or a 4 for x, so I'm going to have f of 4, and that's going to equal 2 times, well, 4 minus 4 is 0. And so I'm going to get 0 on the bottom. 4 plus 3 cubed, 4 minus 3 squared, and 4 minus 4, so that's going to be another 0 on the bottom. 0. And so we're going to have equals 0 over 0. Well, that's undefined. So f of 4 is undefined. All right, so you can't plug in, you can't get f of 4. It just can't be done. So that's not how we're going to do it. What we're going to need to do is find a new function. Let g of x equal the exact same function of f of x almost. G of x is going to be 2 over x plus 3. So this is a trick we can do. X minus 3 squared. Notice that g of x does not have an x minus 4 in the top or in the bottom. Now, if you check f of 5 and you check g of 5, they will be equal. Right? So I can say f of 5 equals g of 5. We could say that g of 9 is equal to f of 9. G of x and f of x, so f of x will equal g of x if x is not equal to 4. So f of x does not equal g of x at all. But when x does not equal 4, well, then they are now equal. Okay? The one problem is you can't plug in a 4 for f of x to tell me where that hole is. But you can plug in a 4 for g of x. So let's go g of 4, and that equals 2 over 7 cubed times 1 squared. Well, that equals 2 over 343. So g of 4, if I were to graph g of 4, I know, or sorry, g of x, I know that when g is 4, g of x is 4 comma 2 over 343. So if I were to graph f of x on the same thing, well, that 4 over 243, that's going to be a hole, an open hole. That's the only place where it doesn't exist. But it's still going to be at the same, like all the other points are going to come towards it in the same way because all the other values for g of x are the same as for f of x. They're all the exact same values. The only difference is right here at that one spot. So the way to find the hole is to let a different equation be the same thing but without that factor of x minus 4, x minus 4. Get rid of that factor on it, and then you can take a look. Where is g of 4? Well, that's where f of 4's hole would be. So it turns out that there isn't a hole at 4 comma 0 at all. Right? That's not true at all. That's just a made-up thing. All right, in terms of communication, there's a hole at, okay, let's just assume that this was written as 4 comma 2 over 343. Like the location was right. It's hard for me to tell. It says the degree on the bottom is bigger than the degree on the top. That makes me feel like that's the explanation for this. So it's not really that clear. I think what they meant was since the degree on the bottom, which is the denominator, I assume they mean, is greater than the degree on the top, which is true, that's why the horizontal asymptote is at y equals 0. But it's not really clear that this explanation belongs to this. Remember, this is a test. You're doing your best work. You're making things as clear as possible. So that's a thing that you really have to worry about as well for your communication. Right? So the horizontal asymptote is at y equals 0. That's great. Y equals 0, let's go over this because a lot of people are having a hard time with this. Y equals 0 is literally an equation. Y equals 0. It's saying every point on this plane that satisfies this equation. So if I have 1 comma 1, that does not satisfy this equation because in this case y equals 1. If I have 3 comma 1, that does not satisfy that equation because because y equals 1 again. The only things that satisfy that equation are 0, 0, 1, 0, 2, 0, 5, 0, 1.10, everything's 0. So all these dots satisfy the equation that y equals 0. And there are no other dots, like everything on this x-axis satisfies that equation. Its y value is 0, and nothing above and nothing below satisfies that equation. So this is actually the equation of this line. These are all the points that satisfy it, right? So when you're saying there's an asymptote at that line, that's really good. What you're saying is the asymptote. Now, by the way, this is not part of our graph. This is the equation of our graph up here, right in here. This is just the asymptote. So the asymptote, since it's not actually points on our graph, we have to draw it with a dotted line to say, hey, no, this, just because there's a line here, doesn't mean that any of these points is necessarily on our actual curve. That's just the line that our graph will eventually follow when it goes off to the right and to the left. Okay, so that's well done. Negative 6, 0. Let's find where that is. So negative 6, let's say that's right around here, and 0. That's a point right there. Negative 2, 0. Well, that's a point right there. That's just a point on the plane. And it says here, our vertical asymptotes. Well, a point, number one, can't be vertical, right? And an asymptote is often a straight line, but it's never just a point. That's not an asymptote at all. I think what this person means is they want to say that this, when x is equal to -6, there's a vertical line that will be the asymptote because somehow this curve is going to follow that vertical line. Well, if you're trying to say that, you can't just give me one point on that line. That would just be this one point. You have to give me every point on this line. Well, if you're going to be giving me multiple points, and you obviously don't want to list all infinity of them, the best way to do that is to give me an equation, right? Is there an equation that satisfies all of these points right here, but no other points at all? And yes, there is. The equation is x equals -6. If you notice, every point on this line has an x value of -6. This is -6, -8. Up here is -6, -7, -6, -3 here, -6, -6, +8. All of these lines have -6 in it. So the proper way to describe that asymptote is x equals -6, not -6, 0. And of course, this one right here is x equals -2. That is an equation where every point on this curve satisfies x equals -2. So it's a clever way of writing millions and millions and millions and millions of points all in one little shot, in one little equation. And that was actually the main point that I wanted to get across in this first video, right? If you want to tell me about a place on the graph, this is in the xy plane. You can't just tell me 3, for example. Like if I just said the number 3, well, where is 3? Do you mean 3, 0? Do you mean 3, 5? Do you mean 1, 3? Which would be like here, 1, 3. Do you mean x equals 3, which is like the whole line up and down? That's every single place that starts with a 3. Do you mean y equals 3? That's this whole line across here where every single y value, like every single point ends with a 3. Every single y value is a 3. What do you mean when you just say 3? Like it makes no sense at all, right? So every single point on this plane has an x and a y value, and I need to know both of them. There are exceptions, like when you say, what's the x-intercept? You can say the x-intercept is 7. Well, that's because we're saying it's the x-intercept. We're telling you that the y value is 0. When you say x-intercept, we're saying that it's on this x-axis, which means we're telling you this is the same thing as saying 7, 0. And if I ask you for the y-intercept, then yeah, it's okay to just say 5 because I know that that means 0, 5. The fact that we said y-intercept insinuates that the first part of your ordered pair is 0. And the fact that you say x-intercept insinuates that the y value is 0. So these really aren't exceptions, right? When I say y-intercept, I'm telling you one of the coordinates, and you just have to tell me the other coordinate. If I say x-intercept, I'm telling you that second coordinate is 0. You have to tell me the first coordinate. But if I don't tell you x-intercept or y-intercept, and I just say the point 5, that makes no sense. I have no idea what you're saying. I don't know if you mean 5, 0, 5, 1, 5, 2, 5, 3, 5, -1. X is equal to 5, which is all these values. Y is equal to 5, which would be all of the, like there's just so many different things. It makes no sense that way. And the other way around is when I want to know all of the points, like where x is -6, I don't want just the one point. I want all of those points for x is -6. All right, here's another one where I see a similar problem. It says the hole in the equation is x plus 4. Well, if I'm looking for a place on the graph, I have no idea where x plus 4 is. I don't even know what the x value is there. Like x plus 4, do you mean x plus 4 comma 3? I don't even know where that is. That depends on x. So like when x is 5, I guess this is 9 comma 3. Like I can't think of any situation where I would give you a point where it's x plus 4 comma 3. So that can't be it. It's meaningless, this x plus 4. Now I do see that there was an x plus 4 factor in the equation, but that sure doesn't tell me that there's a hole on the graph at x. Like I wouldn't even know where that is. Like where is this x plus 4 thing? There's no spot on this graph that would be x plus 4. Like this would be like maybe 8 comma 3. This would be over here. It would be like negative 3 comma 5. I don't know. Like these spots on the thing are clearly, you'd have to give an ordered pair to tell me where it is, right? So x plus 4 just isn't doing it for me at all. Now I can see that they're looking at this to say, oh, this is something that's going to give me, this gives me a hint that there must be a hole in the graph when I graph it, okay? Now, if you look again here, this is said to be equal to f of x, but that's impossible. This one right here is f of x. This is clearly a different equation because this one doesn't have a hole and this one does have a hole. So how do we rectify that problem? Now I understand that these two are very, 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 very similar graphs, but the point is this bottom one doesn't have a hole, right? So what we need to do is make a new graph, a new function, and call it, say, let g of x equal x plus 3 over x minus 2 x plus 5. Right? Now if you actually want to find the hole in f of x, you can use g of x as a tool. So you know that g of, let's say, 9 equals f of 9. If you plug in a 9 for g, if you plug in 9 here and you plug in a 9 there, you can check it out. It's going to be the same. G of 20 equals f of 20. The only thing that's not true is g of negative 4 does not equal f of negative 4. That's the only difference. So basically, if this is the graph of g of x, this is the graph of f of x. It's all the exact same, except that 4, there's no value there. Right? So to find the hole, you can't plug in, you can't find f of 4. That wouldn't make any, or f of negative 4. That, I guess I should have put that hole on this side, negative 4. My bad. You can't put f of negative 4 into the equation because you're just going to get 0 over 0. But you can do g of negative 4. If you find g of negative 4, so negative 4 plus 3 is going to be equal to negative 1. Negative 4 minus 2 is negative 6. And negative 4 plus 5 is just 1. So this is equal to 1/6. So since g of negative 4 is equal to 1/6, 1/6 right here, well then f of negative 4 must go through everything except it has a hole right there, which means the hole is at negative 4 comma 1/6. Right? The hole on f of x is where g of x, where x is equal to 4 for g of x. Or sorry, negative 4. I keep saying 4, but it's a negative 4. All right, so the hole is at negative 4 comma 1/6. Now this is an actual place on the graph. We can identify that spot right there. That's where the hole is. It is certainly not at x minus 4, x plus 4, or whatever it was said here. That's not even a place on the graph at all. And I do want to address this as well, as it cancels out in the numerator and denominator. Well, no, it doesn't. The whole point is it does not cancel out. If it did cancel out, well then we'd have no problem, and we just write f of negative 4 equals 1/6, and it wouldn't have a hole at all. Right? If it does cancel out, then we have no problem plugging in a negative 4. It does not cancel out. Right? You can write a different equation g of x where you kind of get rid of it, but that's no longer our equation. That's just an equation that's helpful to find our whole. But it definitely does not actually cancel out. Now it does cancel out everywhere else except where x is -4, but when we're talking about the whole, that's the one spot we care about. So don't say that it cancels out in the numerator and denominator, making it a whole. That's the one place where it doesn't cancel out, which is the reason we have a whole, right? Because it doesn't cancel out, it becomes undefined. You actually get a 0 in the denominator, which is why we have ourselves a whole here. Now I do get why that was said, because like for example, this x minus 2, there's no x minus 2 to cancel with it, so you think, oh, these ones cancel and this one doesn't. Well, no, this one doesn't actually cancel. It's sitting there. It plays an important role in this equation. It's the thing that gives it a whole. But in every other situation, like when x is 5, then this is going to be 9 over 9, then it cancels. When x is 10, yes, it cancels. The only time it doesn't cancel is what we're talking about here. And here it says the equation has two vertical asymptotes. Well, I'd say the graph has asymptotes, right? The equation doesn't have any asymptotes, but I understand what they're trying to say. So the graph has two vertical asymptotes as shown in the denominator. Not exactly, but there's evidence in the denominator, right? So you'd find this by finding the values of x that would make the bottom 0 but not the top. I agree with that. But it's not really that specific. I wish it would have said where those asymptotes would be. So those asymptotes would be at when x is equal to, now we don't just want the one point right here. We're not talking about a point on the actual curve. We're talking about an asymptote that the curve is going to follow. So this entire line is included. Now this entire line has many points on it. 2, 5, 2, 6, 2, 7, 2, 8, 2, 8.1, 2, 8.3, 2, -8.3. So the only thing that these points all have in common is that their x value is equal to 2. So this equation satisfies every point on this curve and no other points. So this is the equation that satisfies that line. Okay, so when you write that equation, you're saying every single point on this line is just an easier way than to write all infinite points. And of course the other line is going to be at x equals -5. Again, that's a list of many points in a very efficient way. That equation is a list of points. So when you're talking about a place on the graph, I either want an x comma y value, both x and y values, or I want an equation that defines a whole bunch of points, right? So 3x plus 5, that would be like all of these points on this oblique line. All right, let's see here. For the vertical asymptote, there are two answers on the bottom that equal 0. X plus 4, x minus 6. Well, they might not equal 0. It depends what x is. So I guess when x is -4, that equals 0, but this one doesn't. So no, there are never two answers on the bottom that equal 0. There's either this one equals 0, or this one equals 0, or none of them equal 0. Like when x is 5, none of them do. Right? So it says in this equation there is one 0, which is x minus 2. Well, x minus 2 isn't a 0 at all. A 0 is a value of x that makes the function equal 0. Okay, well the value of x isn't x minus 2. The value of x minus 2 is x minus 2. Right? So if I said that x is equal to x minus 2, well that just wouldn't make any sense. That means that 0 is equal to -2, which is not true at all. So no, this cannot, x minus 2 cannot be a 0. Right? Zeros can be an actual number. So when you want your 0, you're assuming so x can equal, let's say x can equal 2, and you're assuming that y is going to equal 0 in that case. Okay, so your zeros are all the x values where y equals 0. So this is one of those situations where I can say the 0 is 5, and that would make sense, right? Because 5 is the x value that would make a y value 0 possibly. That's only if x minus 5 was a factor in the numerator. Now, these are factors. X plus 4, x minus 6, these are factors that you can have. X minus 2, these are called factors. These are the things that multiply by each other to make up the polynomial. Okay, so you can call these factors, but you cannot call them zeros, you cannot call them asymptotes, you cannot call them points. You can only call them factors. So again, here you see there is one whole x minus 4. Well, no, x minus 4 is a factor in the equation. The whole is going to be 4 comma something. This is going to be a point on the curve, but it's not going to be x minus 4, certainly. That's not a place on any graph ever. So I can see at the bottom here it says this equation also shows there is zeros on the bottom and not on top. This equation shows that there were no holes because the top and bottom are both not equal to 0. I think what that was trying to say is there's no x value that would make the top and bottom equal to 0, right? Because this right here is not true, right? This equation shows that there were no holes because the bottom and top are both not equal to 0. Well, sometimes the bottom is and sometimes the top is. It's just there's no one x value that makes them both 0, and that's how you would know that there's no hole in that graph. All right, hopefully you guys are catching on and you'll be able to pick out some of these mistakes. If you want to pause the video and try to see if you can find some mistakes here, let's see what we got. I don't know why people are putting equals y on the right hand side. I guess it doesn't really matter. It's interesting though. Usually you do y equals. Horizontal asymptote of y equals 0. I like that. A horizontal asymptote of y equals 0. Y equals 0 literally defines the x-axis. It's all the places where y is equal to 0. Because the top is smaller degree than degree on bottom. So the top degree, I guess you could say, the top degree is smaller than the degree on the bottom. Okay, no need to use shorthand on a test, We can write it all correctly if we want. Vertical asymptotes are x equals -3 and 5. Yeah, I'll accept that. X equals -3. That's right here. You could probably have separated it to x equals -3 and x equals 5 because it's two separate equations. But that makes sense at least. A whole is -4. Oof, okay, -4 isn't a place. Like nobody in this class would be able to find where -4 is on this graph. Right, you can say I could find -4, 0. But I don't even think the whole will be at -4, 0. Right, let's try. Let's actually plug in. So we'd have to, so this is y. We'd have to like say let, h of x or something like that equal this new function, which would be x minus 2 over x plus 3 x minus 5. And keep in mind that h of x is very, very similar to y. It's going to be the exact same graph except at x equals -4. Right? So we can, if we were to graph h of x, we would have the exact same graph as this y, except it wouldn't have a hole. But we can see where the hole will be by finding h of -4. So let's find h of -4. You got -6 over -4 plus 3 is -1. -4 minus 5 is -9. And so that's going to equal, this is going to be positive, so -2 thirds. And so, yeah, certainly the whole, we all knew it wasn't going to be at -4 because that's not even a thing. But it was going to be at -4 comma something. So we should have said the whole is at -4. Let's get rid of this. -4 comma -2/3, and that is a place where I can get on board. I can say that's right here. -4 comma to -2/3. There we go. So now we actually know where our hole is. All right, take a second. Tell me what you think of this one. So I see horizontal asymptote at y equals 0. That's what we were talking about. That's beautiful. Y equals 0 is the set of points that are along the x-axis, and it is where the horizontal asymptote is. So I'm not saying horizontal asymptote equals y equals 0. You're saying horizontal asymptote is at the line y equals 0. It's beautiful. This is caused by the degree of the denominator being greater than the degree of the numerator. I agree. That works for me. At least one vertical asymptote. So this is caused by zeros in the denominator which are not canceled out by the numerator. Okay, so that I have a problem with, because even if there was a hole, you would not cancel it out. I think what they mean is there's no time for any x value that you would cancel it out. But it's not exactly the wording that we would want to go with. But I don't have a huge problem with this wording. Like, for someone who's just learning it, it's a good way to think about it. At least one hole. This is caused by zeros canceled out due to appearing in the numerator and the denominator. Okay, they will definitely not be canceled out. This is definitely a problem, right? They won't be canceled out. If they were canceled out, then we wouldn't have a hole, right? That's the whole point. We could say something like, this is because there is a 0 in the top and the bottom at that x value. To find it, we can make a new function that doesn't have a hole, that's the same in every other place, and then we can find that hole by plugging in that value of x into our equation. But we certainly cannot say that they cancel out. They're there for a reason. They do not cancel out. Now, everywhere else, they actually do cancel out. But that's not the point. Here we're talking about our hole, and that's the one spot where you cannot cancel them out. And I know this is silly, but for some reason people put boxes around the expression. That's not even an equation at all. And then they put the equals f of x on the outside. Like, I don't see why this is the important part. I think this f of x is a very important part of the equation as well. So please, if you're going to box your equation, box your full equation. And this is a strange thing. Usually you don't put that there. So I would say f of x equals, and I would keep my box around the whole f of x. Now, you don't have to say x can't be 2, 5, or 8. It can't be 2, 5, or 8. You can just see that, because when I plug in a 2, a 5, or an 8, I'm just going to get undefined. So it's already not part of the domain, because it would be that on the bottom. But it's perfectly acceptable to do that. I don't mind you saying x cannot be 2, 5, or 8. This curly bracket isn't exactly appropriate here, but I understand what you're getting at here. All right, this is a new one. Maybe you can pause and see if you can figure out what I'm going to say about it. All right, so horizontal asymptote at y equals 0. That's beautiful, as long as it's true. Is the degree on top? The degree on the top is 3. The degree on the bottom is 4. Yep. I do remember someone saying that there are more degrees on the bottom than on the top. I don't know if I would say there are more degrees. It's just a higher degree, right? The numerator has less degrees. Oh, this is the person. Numerator has less degrees than the denominator. No, the degree that it has is higher. So the numerator has a lower degree than the denominator. Therefore, a horizontal asymptote will be in the graph, you can say. Will be in the graph. Actually say what you're trying to say. Don't just like give keywords. Therefore, horizontal asymptote. To me, that's not a full explanation. This N3D4, I can figure out what they're trying to say is that the degree in the denominator is 3, but since there's no definition, like let n be the degree in the numerator, until you do that, then you can't exactly say, well, it's not even an equal sign, but like I can't decipher what is going on in your brain just because n and d is there, right? So that's usually not going to be good enough for me. I didn't have a huge problem with it there because I did understand what you were saying, but that's not the best practice, right? You don't just make up new symbols and throw it in there. You have to explain what you're doing. Okay, vertical asymptote, factor in the denominator but not the numerator. I would actually accept that, but the problem is x minus 7 is in the numerator. It's totally wrong. No, they're right. There is a vertical asymptote at x equals 7. Vertical asymptote at x equals 7. Not at x minus 7, at x equals 7. But this is an incorrect statement. It says, but not in the numerator at x minus 7. That's not true at all. I think this requires further explanation if you're going to do that. You can say that it's in the numerator and in the denominator, but as x approaches 7, it does get higher and higher or lower and lower depending on what side you're on. So it is actually a vertical asymptote. There are many ways to explain it, but it's not good enough to say something that's incorrect. It says not in the numerator. That's not true. There is an x minus 7 in the numerator. Whole, factor that is canceled out of both numerator and denominator. Not true. That's not true. It's not canceled out. It's sitting there still. For example, x plus 4. See? It's not canceled out. Right? So you can say factor that cancels out of both numerator and denominator for every value of x that doesn't make the factor equal 0. That would be true because it can cancel out for everything except at x equals negative 4. Okay, now I don't like x plus, like just having the x plus 4 sitting there. That requires a greater explanation as well. And are you trying to tell me that the whole is at x plus 4? Because that's not true. The whole is at negative 4 comma. Let's see. Let's let g of x equal x minus 7 x plus 8 over x minus 7 squared x minus 1 and find g of negative 4, and that will tell you where f of negative 4 has a, or where f of x has a whole. And I'm not going to bother doing that. I'm sure you guys can do that on your own. All right, function 1, horizontal asymptote y equals 0, vertical okay. I'm not sure what's going on here. So x in the exponent means that this is no longer a polynomial in the numerator. This is an exponential, and rational with an exponential. This is not even a rational equation. Z, I don't know if we're going 3 dimensions here, or we're just doing any letter, A, B, C, D. So this is not the form of a rational at all, right? So I definitely do not want to see this at all in this. This really doesn't have anything to do with the question at all. So y, oh, here this is better. Y equals x over x squared. Also, okay, so these are 3 different equations. So I think whoever did this just missed the point of the question. I wanted one equation that had all 3 different things. So different characteristics. These explanations also, I don't think are sufficient for a test, right? We're trying to do our best work and communicate the best. Degree of numerator less than degree of denominator. I'm not sure if I'm supposed to assume that that's why there is an asymptote at y equals 0. I don't know, but this probably the communication should be, I know there's an asymptote at y equals 0 because the degree in the numerator is lower than the degree in the denominator. Like something, a much better explanation on a test, right? We are going for communication grades. All right, this one actually looks promising. Horizontal asymptote at y equals 0. That's an equation of a line that is horizontal. Vertical asymptote at x equals -4. Beautiful. That's the equation of a line. So this is my, let's say my horizontal asymptote. And my vertical asymptote at x equals -4. Love it. But I don't think you could have a hole at -4, -1/8 then. That would be like right here. Well, if this is a vertical asymptote, then definitely don't have a hole here. That doesn't, something's going wrong here. So let's look at the equation, see what's going on. So this, okay, f of x can definitely not be equal to both this and this, because this one has x plus 4 canceled. So you're saying f of x equals x plus 4 over x plus 4 x minus 4, but also f of x equals 1 over x minus 4. Well, that's impossible. These are two different graphs. One of them has a hole and the other doesn't. So no, you can't do that. You can say let g of x equal this very similar graph, and that would be helpful. And then you could find the hole by plugging in, like you can find the hole in f. You can say find the hole in f of x by finding g of, and now I don't know why you'd put in -4. Oh yeah, -4 is where that, so negative, by finding g of -4. And that is equal to g of -4 is 1 over -8. Yep, so sure enough, the hole is actually correct. The problem is there's no vertical asymptote there. That's a hole. There's a vertical asymptote at x equals +4, because that is what is going to get the bottom equal to 0, but not the top equal to 0. Right, so that vertical asymptote was actually incorrect. Since the degree in the denominator is greater than the degree in the numerator, there is a horizontal asymptote when y equals 0. That's excellent. When x equals 4, the denominator is equal to 0, so x equals -4 is a vertical asymptote. Oh no, -4 is not even anything to do with 4. These are, 4 is way over here, -4 is way over here. So just because when x equals 4, it's undefined, it doesn't mean -4 is going to have an asymptote. That's not a thing at all. If you plug in a 4 and you get undefined, well then that's probably where your asymptote's going to go, right? That would be like plugging in a 3 and saying, yep, it's undefined, therefore there must be a vertical asymptote at 17. Like, it's just not the same place at all. So no, that doesn't work. 4 and -4 are two totally different numbers. And there's a hole at, this is excellent. Most people didn't bother finding the actual hole, and this was well done. The problem is they said f of -4 equals 1 over -8, which completely contradicts the fact that there's a hole at -4, -1 over 8. This is saying that it exists, and this is saying that it doesn't exist. That can't be. Because I was able to divide out the factor. Well, if you're able to divide out the factor, well then this is no longer a hole. But you are not able to divide out the factor. What you're able to do is let g of x equal this new equation with the factor divided out. There you go. And now g of x does equal this, and g of negative 4 does equal that. Therefore, the hole in f of x is that. But don't say there's a hole at g of x, because there's no hole at g of x. G of x is clearly goes through negative 4, negative 1/8. Whereas f of x, f of negative 4, is undefined. But g of negative 4 equals negative 1/8. Totally different equations, but very similar everywhere else. All right, what can I say here? F of x is equal to this, sure. Horizontal asymptote at 0. Well, no, 0 isn't even a place. Like, where would I find 0? I can find the origin, which is at 0, comma 0, but not just, that's just not plain 0. Oh, I didn't even try to make a face there. It's kind of neat. I can find 5, comma 0. I can find 0, comma set. There's just no 0. So you can definitely not have a horizontal asymptote at 0. You can have a horizontal asymptote at y equals 0, which is what you actually have, but not just at 0. That is not correct communication. Okay, because top degree is less than bottom degree. Yeah, I can say that. That was fair. Vertical asymptote at, oh, absolutely not. At negative 2, that's not a place on my curve. I think what you mean to say is that x equals negative 2, and that is an actual place on this graph. That's when x is negative 2. It's all these points up and down here. That would be much better, because that would make the denominator equal to 0. Well, what would make the denominator equal? A vertical asymptote doesn't make a denominator equal 0. I think what you mean to say is, because if x equals negative 2, the denominator would equal 0. Okay, so that would be true, but you can't just say because that would make the denominator equal 0. You'd have to tell me what that is. When x equals negative 2, then the denominator is 0. And that is an impossible value. Okay, however, it is not a hole because that point is not meant to be a 0 as well. That, I'm not sure what you meant. I think you're trying to say it is not a hole because when x equals negative 2, the numerator does not equal 0, even though the denominator does equal 0. Okay, we have to use the specific language for math. Hole at 2, I'm assuming you mean hole at x at 2 comma something, right? So x is 2, but you still need to find that y. You can't have just a 2. That could be anywhere along. Well, that could be, actually, it's nowhere, but it could be anywhere. I don't know, is the x2, is the y2, or is, are there several points? Is there one point? That just doesn't make any sense at all, right? So you need to find that other point. And we've gone through this a bunch of times. You can say, let g of x equal 1 over x plus 2. And then you're going to find g of 2 is equal to 1 over 4. Therefore, the hole in f of x is at 2 comma 1 quarter. That's where the hole is, 2 comma 1 quarter, not just at 2. All right, so we don't actually have the equation here, but the wording is there. So let's just look at the wording here. I know there is a vertical asymptote because if you factor out the denominator, you will get x plus 6, x minus 6. Okay, so I think the original equation was x squared minus 36. And by factor out, I think what you factor out, think what they meant was if you factor. So if you just factor. Don't factor it out, then it'll be gone. So let's call this f of x equals that. You'll get x plus 6, x minus 6. Once the x plus 6 from the denominator and x plus 6 from the numerator cancel out, which they will not, but you can let g of x equal 1 over x minus 6. These guys do not cancel out. We have to stop saying that. Not where the whole is anyway. So if you let g of x equal 1 over x minus 6, then you can see where your whole is, and that will be at g of negative 6. That's 1 over negative 12. So this guy has a whole, f of x has a whole at negative 6 comma negative 1 over 12. So it says you will be left with x minus 6 in the denominator. Yep. Since this is a factor that equals 0 in the denominator, after canceling out common factors in both the numerator and denominator, it is a vertical asymptote at x equals 6. X equals 6 is where there's a vertical asymptote. That's beautiful. It is a vertical asymptote. How about there is? There is a vertical asymptote at x equals 6. I'm okay with that. So this one was actually quite good. A couple wording things that could have gone better, but in general that was actually really good. All right, see if you can find any mistakes here. I don't know if there are or not. Let's check it out. Horizontal asymptote at y equals 0. Love it. Yeah, that's exactly what I've been trying to say. Y equals 0 is the equation of the x-axis because the degree of the denominator is bigger than the degree of the numerator. Yeah, it's exactly why. The numerator degree is 2, which is while the denominator is 3. Yeah, beautiful. Vertical asymptote at x equals negative 5. Yeah, that's exactly right. Because, how about, because of the wonderful things he does. So because there is a 0 at the bottom, but not on top. There is a 0 at the bottom. All right, I can accept that. Like basically what they're saying is the polynomial on the bottom will have a 0 where the top will not have a 0. But I understood the point there. So it says when you plug positive 5 into the equation, the numerator will equal 24. Well, that's true, yeah. And the denominator will equal 0, which will give you undefined. Sure, I don't like saying equals undefined. I like to say it is undefined because it's not really equal to undefined. It's undefined, so it can't be equal to anything. There are holes, there are holes at x equals 2, no, and x equals negative 3. Well, sort of. I mean, it's somewhere along x equals 2, but x equals 2 is a full line, and x equals negative 3 is a full line, but holes are only at one little point. Okay, so both these values make the numerator and denominator equal 0, which is undefined. 0 over 0 doesn't exactly equal undefined, but is undefined. So I would say there is a problem with this explanation, because if I have x minus 3 squared over x minus 3 cubed, now the top and the bottom both equal 0 in this case as well, but there is no hole. This is actually an asymptote here. So you'd have to be a little bit more specific than just the fact that they are equal to 0 over 0, right? You have to say that the degree of that factor is the same degree as same degree or lower on the bottom than what it is on the top for it to be a whole. But in general, not too bad. This one, I kind of like this one. A lot of the wording was very good. So I know that's quite a long video for just question 1A, but I think I made a lot of points that should be very, very helpful for improvement. So if you are looking to improve your game here, improve how you are with rationals and your communication, watch this through, let me know, and then just tell me if what you've learned and what you've improved, and we'll see where you are now compared to before.